be here in Rimini today, and thanks so much for having me. Today, I want to talk about, as Ricardo mentioned, HTML-aware ERB and the way we can make it reactive so we can have more reactive rendering capabilities, what you might know from Elixir with like Phoenix Live View and other stuff. So, my name is Marco. I'm a full stack developer and open source contributor, and I've been trying to push the boundaries of what's possible with these real-time server-side rendered web applications and that are using this HTML over the wire approach. For the last few years, I have been focusing on improving the developer tooling in this space, and more recently in the Rails view layer. And this is mostly related to ERB, or embedded Ruby, as we call it. But the thing is, ERB is versatile, so it can be used for pretty much rendering any string. But most often, we are using it in Rails or in Ruby web frameworks as HTML ERB. So it's a combination of HTML tags and these ERB tags, so the combination of the two. And this talk is a continuation of kind of a series of talks I gave last year at Rubycon, RailsConf, and Rails World, which started with this first one, which was about kind of building these tools to make it easy to work with HTML ERB. So at Rubycon last year, I launched a project which came from HTML-AB, and that's kind of the abbreviation for Herb. And this is kind of designed to be a ecosystem of tools, and it's focusing mostly on the parser. And at Rubycon last year, we launched this parser, which had support for parsing from Ruby, from WebAssembly, from Node.js, because it's all written in C. And in the meantime, it kind of evolved into this full tool chain of tools that pretty much does everything from static analysis up to rendering your HTML ERB templates. But I also had this point on the slide here where I was talking about a potential new rendering engine that could be built on top of this new parser. So I want to talk about this awareness of ERB and how this might lead to reactive rendering. And for this, we need to talk about ERB engines. We need to talk about what reactivity actually is and what we are still missing. So first, let's start with Herb. Rails just works, and it keeps working, and all these web frameworks in Ruby also keep working. And for the most part, when you write a web application Ruby and Rails, and if you upgrade it to a new version, they just keep working without having to rewrite most of the things. These patterns are stable, they are conventions that are stable, and that stability is mostly a feature, not a bug. That's also why people keep building these businesses on Ruby and Rails. But the challenge is, how do you kind of innovate in this space where everything is stable without breaking what already works? And in a related notes, we also got some new Ruby developer experience tooling, or this new wave of tools. So with the release of Prism, the new Ruby parser, we have seen all these tools kind of come after it. And on this slide here, which is also borrowed from Stan Lowe, you can see that Prism is pretty much at the foundation of all these tools now. But there's been one spot where we haven't really been focusing on, which is the view layer in Ruby. And I've been asking myself why tools like this never existed before. And I think the reason is mostly because there was nothing to build against. There was no parser to build these kind of tools on top of. So I asked the question, what would become possible if the ERB engine itself that's rendering out templates would also understand the HTML around it? And what if we established a grammar of what this means to formally have HTML ERB in one file? So a formal syntax defines what's valid and what's invalid. That can provide structure, hierarchy, this HTML awareness that these tools can kind of understand and reason about. And thanks to the Prism parser, we can now also understand the Ruby part in these templates. So if you combine the Herb parser with the Prism parser, you pretty much get a full validation before you even try to run your codes. So if you have a missing end tag, it will be catched by these tools. If you have invalid Ruby inside these tags, Prism can catch that. And if you have invalid HTML, Herb can catch that. So establishing this grammar is pretty much what makes all of these other things on top of it possible. And that's kind of what Herb is. It brings these two things together that didn't exist before. So it defines the syntax, kind of the rules of how these HTML EB languages interleave, how they nest, how they relate to each other. And it defines a grammar, kind of find what is valid HTML ERB structure and what it looks like. what is allowed and what isn't, and what the engine can count on to actually run the code. And if you have a syntax and a grammar, you can build a parser on top of that to kind of formalize this. And on top of that, you can build a full tool chain for this HTML ERB templates. And I think this is what was missing. Not just these tools, but just a definition of what it means to have HTML and ERB next to each other. So there's one parser, there's one truth, which means if you try to run this in your editor, if you try to run this in the CLI, if you try to run this in your app while rendering your templates, you have the same errors, you have the same syntax tree, you have the same rules, you have the same structure. This is all being shared. And this is really powerful because if your editor tells you there's something wrong about your templates, you can be sure that this is actually wrong. And if you try to run it, it will also crash at runtime, so you don't need to even try to run it because the editor already told you that something is wrong about it. But it's all powered by the same underlying architecture, and the language server which I built for this kind of brings this to your editor today. You can use this in pretty much all editors that support the language server protocol. And it gives you this instant validation right in the editor that something is wrong about your HTML, ERB, or the combination of the two. It catches missing closing tags, it catches missing syntax or wrong syntax, and it catches Ruby kind of syntax or logic error in your code. There's a lot more in the language server that we cannot talk about today, but it supports the linter, the formatter, toggling comments, and a lot more. So this is all kind of static analysis, but now we want to talk about how we actually render these templates in production. So ERB engines or ERB templates are Ruby, or well, almost Ruby, because we need to be able to run them. We need to convert ERB to Ruby first. And what this means is that we have to kind of take our templates, pass them through a compiler or an engine, and we get Ruby code that our Ruby runtime can actually render and run. And the most popular one today for this is ERB engine, which is also what Rails uses today. And if you give ERB engine a template like this, it will use a regex to split this template into pieces of static and dynamic content. And you can think of this as like strings or Ruby codes as like an array of those. And if you go over each of those and call add text for the static pieces and add expression for the dynamic pieces, we end up with a sequence of instructions of how this template is being compiled. So in this case, we have these three, and under the hood, this will kind of compile a Ruby script, which looks like this. So you try to instantiate the buffer, you append content or the dynamic Ruby into it, and at the very end, you call toString to kind of render this out. So you have the result as a string at the end of the template. This is designed to be evaled. So when you kind of eval this code, you get a rendered template back. So we took our templates, transformed it to Ruby, and now we can render this as part of Ruby code. But you might have noticed that actually there was an error in this template. There's a missing end tag, but the engine just did the work anyway. It didn't kind of complain. So we want to make our engine aware of it so we can build this more advanced feature on top of it. And that's why we need to be able to understand the HTML, because we want to enable this reactivity. So what this means is we want to take our ERB engine and make it a HTML ERB engine, or put differently, instead of string templating, we want it to be HTML templating. And that's kind of what Herb engine enables us to do. So when you try to compile a template that is invalid, it will tell you exactly where something is wrong, and it won't actually let it compile. So it will tell you upfront, which means you cannot actually produce or compile a template that is invalid or will produce invalid HTML. And that's the idea. It's this HTML engine, which is ERB engine API compatible. And let's now see how this kind of works with Herb engine. So this time we have a complete template, which is actually valid. We can use the Herb parser to parse this template, and we will get back a syntax tree, which looks like this. I will zoom in on that one. So you can see there's a document nodes, there's the element inside of it, you have an opening tag, the content, and then the closing tag. And what we can do now is we can implement a visitor, which goes through this tree and kind of navigates all these nodes. And we can implement a compiler that kind of compiles this template into Ruby code. And we can kind of go through each of these nodes and implement the logic for any of them. And you can see the open tag node has these three static strings on the right side. So we can call add text for each of those tokens. For the text nodes, we can do the same thing because we just have a text content. We can just append that. And more interestingly, for the ERB content nodes, we can check if it's a output tag. And if that's the case, call add expression or add code to just kind of append the output. And if we go through this, we get kind of this set of instructions as a result. And if you compare those back to eRuby, you can see we are doing a lot more work and there's a lot more instructions. So this must be more, it's more inefficient, right? But what we can do now under the hood, we can collect these tokens and kind of register what kind of token it is. And for this list of instructions, we get an array that looks like that. So we have a set of tokens with the parts of the string and then also what kind of type it is. And you can also see that we have a sequence of string tokens that are followed by each other. So what we can do is we can do a first pass on this to combine these tokens into one if they are consecutive, and then take that to compile the templates in the end. So if you take this, iterate over these tokens, we can compile the same templates. And then at the end, if you compare this back to eRuby, it's exactly the same codes with the exact same instructions. It should also produce the exact same compiled template. But with the benefit that this guarantees that we have valid HTML, we have a valid assumption that this is going to be valid HTML. And we kind of took it now from being a string template engine to an HTML templating engine, which produces the same output as eRuby does today. So with all this knowledge, we can start to tackle and do more ambitious things, which also means we can improve the error screen in Rails when you kind of have a invalid templates that it can tell you where something went wrong in rendering this. But also, since we have more control over the rendering now, we can also inject more markup in developments. And you can kind of abuse the fact now and inject some more debugging tools in your browser. So Herb will give you these debug tools that can kind of pop up, and you can enable this outlines feature so you can see the outlines of your application and how, like, where the boundaries are of your view files. Then you have the same kind of things for partials and components with different colors. You can hover over those to get the different paths. And more interestingly, you can also click on them to kind of open the editor where this template is defined, so you can go back and forth and iterate on your designs and your UIs. We can also show you where you are using dynamic ERB content. So we know all these purple outlines are where we are using ERB to render content. And there's also an option, so if you hover over them, it will show you what was used to render this exact piece of your template, which is really powerful. Mickey. So yeah, where do we go from here? So we have now this static tooling, we have this rendering mentions improvements. What else do we need? And I was kind of asking a question, what if we could complete the Hopwire story to make all of this kind of be reactive and work nicely? And how would this look like? What if Ruby apps could have all these nice features that the single page application promises or promised to us, but without having to abandon the service that rendered HTML, without having to write these single page applications, and without having to give up full stack Ruby? And I think the missing piece for this is reactivity. And when I talk about reactivity, I want to differentiate between production reactivity, stuff you run in production to have people interact with your app, and also reactivity at development time when you are working on your application. So let's start with production first. Every major ecosystem has tackled reactivity in some way or form. In JavaScript, we got React that introduced the virtual DOM diffing, which is pretty much comparing both trees and then just patch what changed as a result. Svelte moved this in a way because it moved the analysis to the compile time, so it pretty much eliminates the whole runtime overhead. And so it took us a step further with fine-grained reactivity and their signals concepts, where you're pretty much bypassing the whole component tree and just go to exactly where stuff changed and then just update that. So that's really efficient. More closer to us is like Elixir and Phoenix Live View. They have these Heek templates, which are HTML ERB kind of equivalent for EEX, which is embedded Ruby or embedded Elixir. And this also solved with Live EX, which is the compiler that we have now compile time change tracking. We have these slot level updates, And this is pretty much the gold standard for server-side reactivity today. Also in PHP, we got Laravel Livewire, which does very similar things with their Blade templates and the Blade compiler. And one thing all these frameworks have in common, which is more that these engines understand what they are rendering. And they have a graph of dependencies to know what needs to change when something else changes. And that graph is what enables this fine-grained reactivity. And that's something we never had in Ruby. So what I wanted to do is look beyond our own ecosystem. I wanted to see what others are doing well, understand why it works for them, and then bring it back the Ruby way. So I looked at existing tools that we had in Rubyland, which is also Stimulus Reflex and Cable Ready, which are kind of the predecessor to Hotwire. We also had Livewire and Phoenix, as I mentioned, with LiveView, and then all these influences with the JavaScript ecosystem. And that's kind of my goal, to have this initiative of ReActionView, which wants to bring reactivity to the ActionView framework. So the goal is, let's keep what works, what is great, that's already there and what we already have, which is also ERB. We want to kind of add what's missing, and so we don't need any JavaScript frameworks. With the goal of making this as backwards compatible as possible, so all our existing views just work and keep working and just get an upgrade like that. So here's the idea. We have a template, and this template has some states. Whenever state changes, we want to trace your templates of where this is being used, and then only re-render the part that actually changed, and then patch it back to the clients, so only updates whatever just updated, without having to re-render the whole page on every interaction. But for us to be able to do that, we need to understand what's in the template, what control flow structure we are using, what state we have in these templates, how the data flows through your templates and how it's getting passed around. And I again think this was kind of the missing piece here, that we needed to have a grammar and a parser to be able to understand these templates now. And this is what both Prism and Herb now provide to us and enable us to do. So how can we make this reactivity happen? Today, if you have a web server or a Rails app, the client does make a request to your app, the server side processes his requests, and it sends back a full HTML response to the client, and the client shows that. In Rails, this looks like this, where you have like a GET requests, which gets passed to a controller, and then we are rendering a profile show page by the conventions. So we have this whole stack of where this is all flowing through, and for us to be able to understand what's actually happening, we need to understand the render graph. So if you look at our profiles show page here, we can see we have a bunch of render calls here, right? So we need to know, what are you rendering here and how does this look like? Luckily for us, Herb is able to parse these calls now in our templates, and it can give us the relevant information out of those, so we can know and see what other parsers you are referencing and what are you rendering. So we can ask the question, which files are being touched or are being rendered whenever we try to render the profiles show page. And that's what Herb can now provide to us. It can give us a tree or a graph of all the templates that are involved to render a profile show page in this case. So you can see all the partials and all the components it calls out to. We can also reverse this operation to say, who is rendering this partial? So you can see which other parts are rendering this, and you can also see where it's reachable from, either directly or indirectly. So you know, when this partial changes, where does it show up in the app? On which pages does it show up? So you can kind of get an understanding of what's happening in your app. And since you have the full understanding of all what's happening in our views, we can also give you more advanced diagnostics now to say, we couldn't resolve these render calls because they do some meta programming or some more advanced things in Ruby. And we can also tell you if you have unused partials because we couldn't reference them and couldn't see a render call for them, so you might be able to remove them. The second challenge was to trace these dependencies so we know what's dependent on each other. And surprisingly, ERB itself is quite suited for this, because every ERB tag itself has a simple contract. So if you take this template here and we kind of compare it to the compiled output side by side, we can see that this items each get pretty much translated one-to-one to the compiled version. But you can also see that the item with the output tag gets prepended as underscore buff and then the shovel operator, and we call toString on it at the end. So what we are saying is whenever we are calling out to a ERB output tag, we are expecting a string as a result, and we shovel this into the buffer. And in the end, you don't really care what's inside of these tags. You just care that we are getting a string back from that operation. So it takes some state in, it produces some string as the output. And the same is true for the whole template itself. Whenever you render a template, you get a string back as a result of this operation. And this is what allows us to build out the reactivity, which also ties into the next challenge that we need to know what are helpers, what are local variables, and so on. So if we have a template, we want to know what is user, what is linked to, what is user path, and so on. Are those locals? Are those path helpers? Are those ActionView tag helpers? We need to know what these things are. Again, luckily for us, Prism makes it somewhat trivial for us to figure out what's happening in these templates, so we can do some static analysis to figure this out. But we also had to build something which I called a registry for these ActionView helpers, so we can look up these helpers and know if they exist and what they are doing. So what we do is we take all the references we find in your templates, subtract the strict locals, subtract the path helpers, and all these other helpers, and what's left is pretty much the unresolved references. Which means we need to kind of resolve all of them to be able to enable this reactivity. This is an approximation. It's not 100% accurate in most cases, but the good thing is that we can do this like on a per route basis. So we can say it can be gradual. We can also only do it on pages where we need high interactivity, high fidelity, and where we need this reactivity. So you don't need to patch all views at once, but you can kind of slowly, gradually do this. But also we can give you warnings for these unresolved references. So when you ask Herb today now if this new Herb ActionView commands, it will tell you here are the locals being used, here are all the locals it receives from the render graph. It sees what's being passed as locals, and it can also resolve all the helper calls. We can also do this for all templates. It will tell us what's wrong about them, and we also have at the very end some warnings to say these are the ones we couldn't resolve, so you might want to fix them. You can either fix them by defining these strict locals, or we might be able to do some other way to explicitly declare what these references are doing. But the beautiful thing is we can now use our own tooling, the Herb tooling, to be able to give you feedback on your views to improve them and make them kind of ready for reactivity. The other challenge was these tag helpers, as I mentioned earlier, but the other thing is that we are using them in our view files often. So in this case, if you kind of want to know what we need to re-render whenever kind of post changes, we want to kind of do the minimal amount of operations. And in this case, if you look at where post is being used, it's these three places. And we learned earlier that you just care about the string output from these operations. So if you take the first one, we can see we are using DOM-ID here. We don't care about the content, but we know, okay, we need to look at this whole tag now. And since this is a block, we need to look at the whole block and then also at its contents. And then we are pretty much at the point where we need to rerun the whole template as a result, which is not ideal. But Herb now supports that we can detect these helpers. And what this means is we can kind of take these templates and transpile it into a compatible form of what it would look like if it would be written as HTML ERB together. So it can do this. So it knows this is what's being rendered at the ends. And now we can see that we actually only target these two attributes and the content of this A tag. And this makes it much more efficient for us to figure out what we need to update when something changes here, instead of just having to rerun the whole template every time. And this kind of operation is now allowing us to do this fine-grained reactivity, or allows us to build this out. And as a nice side effect, we can also now just bring this back into our editor. So when you hover over these tag helpers, it can show you the equivalent HTML ERB as it would be if you would have typed it out yourself, which is super helpful for debugging back and forth. The other challenge was to track which changes are going to affect which HTML nodes in your templates. So we need to build a reverse dependency index. And what I mean by that is, so when we kind of look at post again in this case, we see it's being used in these two places. And for us to be able to update the post title in this case, we need also to know that it's enclosed in the h1 tag. So we want to kind of build out this map to say whenever post changes, we want to look at all these other nodes in our templates. So when we want to re-render posts, we don't have to look at the whole template, but only at these places. And this allows us to compute the minimal amount of changes that we need to update or reflect changes in the UI. So Herb today knows all these helpers. It knows about these strict locals, about these locals being passed around, these instance variables, and so on. It can understand the render graph, it can understand these dependencies, it can resolve these tag helpers, and also know which DOM nodes are going to be affected by these changes. But that's what we have today. We aren't quite ready for production activity yet. But all these tools give us now the primitives and the foundation to build out this whole reactivity vision. So we can wire them up now and build something like Phoenix Live View for the server-side reactivity in Ruby, which is this whole reaction view idea. That's it for production activity. And now I want to kind of turn into this other part of dev time reactivity. For a long time, we had these tools, including when you had Webpacker, which is like Webpack Dev Server and the Vite Dev Server. So when you are working on these files, you update them, and then it will kind of instantly update the page in your browser. It didn't require full page reloads. It just kind of updated whatever it needed to update. But for us to be able to do this in Ruby, we needed to build something else. So we needed to figure out a diffing engine that we can compare to syntax trees that we have in Herb. So the API for this is simple. You give it a old source and a new source, and it will give you the minimal amount of operations. You can check out the full implementation here. It's quite tricky to technical, but it's here. But the short of it is that we can now give it a templates, give it a other templates, and it will tell us how it changed and what changed. In this case, text changed, so it can do it before and after. It can do the same for attributes. So when you add an attribute, it can tell us we just add an attribute, and that's what we have. So it's more structured than just saying, here, this text changed, but it knows here we just added an attribute. This also works for HTML ERB, it works for ERB, for HTML elements, and so on. And now you can maybe see where this is going. So we want to implement this dev server for Herb itself. So we get the hot reloading in developments. You can run herb dev, start this up. It will index all your files, and when it's ready, it opens the WebSocket server locally. It uses herb diff under the hood to compare all the new version. And when you go and change the content, it will kind of emit these updates on the left side. So all you have to do now is go to your proc file dev, add this line for adding the dev server here. And then the herb dev tools in your browser will connect to it using the WebSocket server. So when you update your templates in real time, it will go and update the browser in real time and just patches whatever changed as a result. It also works for partials. So when you update a partial, it's kind of going to update all the instances on the same page. And then also, if you introduce new syntax errors, it can also show you the errors right when you have them. And when you solve them, they go away and update the browser. So no full page refresh, just incremental updates emitted by this new diffing engine. And as a bonus here, we can also do some compile time optimization now, which is funny because these are just side effects now because we want to make reactivity work. But now that they also improve the performance of this whole thing. One of them is these compile time optimizations for these tag helpers, which I mentioned earlier. Since we are kind of having this templates and kind of translating it into this new other formats, we can, instead of compiling the top version, we compile the bottom version, which means there's less Ruby, so it's going to be faster. And there's some early benchmarks here, but there is some performance to be gained here. But it shows that in some cases, it's up to 150 times faster if it's mostly static content. And on a more realistic page, it's up to 3 times till like up to 22 times faster. So it's really there's something to be gained here. The other thing is we can also optimize these render calls, because at runtime, whenever you call render partial, it needs to do a file lookup to find this exact partial in your templates. And this is the slowest part today in rendering ERB templates. But if you can kind of swap out this render partial call at runtime and resolve it at compile time and replace it with the internal action view method that is being compiled to, you can also see some improvements here, which were like up to 10 times faster just for render partial benchmarks. So yeah, some of these results almost sound too good to be true, but there is some performance to be gained here as kind of a side effect of doing this work for reactivity. So yeah, to conclude, I hope that this talk has given you an overview of Herb potential and how we are trying to achieve this reactivity in ERB. The Prism partial had a big effect on the tooling landscape for Ruby itself and the tooling around it, and I think that Herb can do the same for HTML templating and tooling. And I think this also just manifested yesterday because GitHub has adopted Herb in their code base for github.com, which is now analyzing all their 10,000 view files on every push, which is a big achievement. So yeah, this is all part now and released as the Herb 0.10 version. And it ships with all these features I talked about today, including the diffing engine, the dev server, this new action view command, and the whole action view render graph. So now with this whole template tool chain, we have the foundation to make activity possible. And I think that this can complete the hotwire story with the missing pieces here. So we can keep writing Ruby and build even more ambitious and even less complex Rails apps. And with these foundations, I think we can achieve this vision of what I set out to do with ReActionView. Some acknowledgements. I want to thank everybody who contributed to Herb and the reported issues, including all the contributors, which some of them are here today too. Thank you. And then give a big thanks to all my GitHub sponsors who have been supporting this work over the last few years. So thanks to all of you. And a special mention for the GEM Fellowship, which allowed me to work on this reactivity features as part of the grants they gave me for this GEM Fellowship. So please try the tools, report issues, give feedback, give it a star on GitHub, and check out the docs on HerbDev tools. Thank you.